Okay, 6th graders, we're going to skip to lesson 6 in this chapter. So this is lesson 15.6. Stop humming and singing. Okay. Lesson 15.6 is all about circles. Let's go over some of the parts of the circle first. Okay? There are certain parts that have certain names. Okay? For example, the very middle of the circle is called the
center.
The center. So draw a circle in your notes. Put a dot in the middle. And label it C. Center. Then draw a line from one side of the circle, from one edge of the circle, through the center to the other edge of the circle. That line is called the diameter of the circle, or D, if you see it in a formula. The diameter is the distance all the way across the circle through the center. Now, if we take half and go halfway, or from the center to the edge of the circle, that's a different line. Here's the drawing of that. That's a different line called the radius. There we go. The radius, the center to the edge. Or the radius is half the diameter. So if you know what the diameter is, you can find the radius by dividing it by 2. That's what this says. Radius equals the diameter divided by 2. Or if you know what the radius is, the diameter is equal to a radius times 2. Yep. Okay. Then, a portion of the circle, or a piece of the pie, is called a chord. And the line, the arc line that goes along the chord is called an arc. Okay? Then, there's a certain name for the perimeter of the circle, the line that goes around it. In other words, if we had a string, and we put that string on this line, all the way around, and then we took the string and stretched it out and measured it, we would have found the what of the circle?
Circumference.
The circumference. Yep. The line that goes all the way around, the perimeter of the circle. It's called the circumference. And we use a formula to find the circumference. We can find the circumference by knowing what the diameter is, and then multiplying it by pi, Pi, which we round to 3.14. Okay? 3.14. That's the rounded number that we use for pi. Okay? So, if the diameter was 100, what would the circumference be? If the diameter was 100, without a calculator, can you do 3.14 times 100?
314.
Yeah, it's 314. It's moving the decimal place over 2 places. Right? If the diameter was 100, 100 times 3.14 would be 314. The circumference. Okay? Now, The area of the circle is not the line that goes around it, is it? That's the amount of space that it takes up. Okay, so that has to be a different formula. Here's the area formula. It's the radius squared times pi. What does radius squared mean? It means the number, the radius, times itself, and then times 3.14. So what if the radius was 10? What would the area be? If r equals 10, what would the area be? How would we find it? Let's go back and talk about how would we find the area if the radius was 10? What would we do? There's got to be more than 2 people that know. No, not 2 hands. Oh, we have 4 hands, but still only 2 people. 3 people. Radius squared. We're trying to find the area of a circle that has a radius of 10. Garrett. Again, it's 314. Why? What would we do?
Because 10 times 10 is 100, and 100 times 3
10 squared times 3.14 is 10 times 10, which is 100, and 100 times 3.14 is 314 again. Okay?
Is pi supposed to be
Pi.
in that?
Pi. Yep, that's a real word. Okay? What's a half circle called?
A semicircle.
Semicircle. A quarter circle.
Why am I writing these numbers?
What's a quarter circle?
Quarter circle. Quarter.
A quarter. Yep. All right. So let's go on to another concept. Yep. And wait. No. So we've been talking about angles, and the total angle measure in a triangle, for example, or a rectangle. The angles in a circle add up to what? 360 degrees also. Okay? But instead of the angles being on the outsides, like on a rectangle, the angles are in the what? In the middle. We call those the central angles. The central angles equal 360 degrees. Okay? So, what if this one is 120 and this one is 120 degrees? What would this one be?
120. Right?
How do you know that one would be 120?
Because they're all equal. Divided by 3.
How do you know they're all equal?
Because they look equal.
We don't know for sure.
No.
They look
You can't go by looks. Not when you know what the total is. If you know what the total is, then they have to equal 360. And 120 plus 120 is 240. So the remaining amount is 120.
I told you.
But it's not because we can look at it and say, oh, that looks like 120 also.
But it has to be.
We know for a fact it is. Why, AJ?
Because you add all three up and then you subtract 240 and you get 10. Or you add all two up and then you
Yeah.
subtract.
Put the cube away. So we find the missing angles by subtracting it from what number? What is the total? 360 degrees. All right. Those are called the central angles. I think that's it. I think that's what you need to know for today's lesson. So in your packet, oh wait, you don't have a packet. Never mind.
Times are.
Go to page 458. Yep, page 458. And let's see, let's do 7 to 36 evens. No, all. 7 to 36 all. Work on those. Those are identifying parts of the circle, finding the radius and the diameter, and finding the central angles.
Bye!